Hello everyone and welcome to chapter 2 of this series, and in today's video we are going to be talking about variables, data types, type convention and handling user input. And at the end of the video we are going to be able to create a mini bio generation program. Alright, so what are variables? Well, variables are well labeled containers for storing data or values that will be used in our computer program. So a variable has two parts, which is the name and the value. So let's say the name of the variable is, should I say, price, and the variable is 3.5. So if the part on the right, which is after the quality operator, is the value, and the part on the left is the name for the variables. And variables are useful for our code, so it's going to avoid clumsiness in our code and make it dynamic rather than us statically putting values into every part of our code when we build. And then the next thing we'll be looking at is data types. So everything that's always at the right of the variable is an example of a data type, and that's what we'll be looking at today. So the first data type we'll be looking at is a string. A string is any sequence of characters that is being enclosed in a quotation mark. So example, a name, which is this, is a string because it's being enclosed in a quotation mark, and it can be enclosed in a double quotation mark or single quotation mark. All is going to work. So if you go ahead and print the name, I'm going to open the terminal, and then I'm going to run python main.py, and we are going to see manual. And to check the name of the type of the variable, if we pass the type checker here, consider the type is a class of string. The next class we are looking at is the integer, and an integer refers to a whole number in English. So I'm going to come here and set the age and an imaginary age 25. So if you check the type of age, because it's a whole number, we are going to collect a class of integer. The next type is the float, and the float is a floating point number. So I'm going to check the type of price we created at the top, and the price is a float because it has the decimal part and a whole number part. So if you check the type of price, we're going to see a float. The next step we have is a complex, and a complex is used to represent any data type that uses a letter part and a number type. You'll not really see much of it except you are going into data analysis and the rest, but it's just good, So a complex number like this one is just basically any number that has two parts, the number and the letter. And you can check the type of a complex number, and then you are going to find out that is a class of complex. Next is a bool, and a bool is a kind of data type that represents two logical values, which is the true or false. So if a value is not true, it is false. So if you want to check whether the user is in schooling, you can set this to true. And if you check the type of the schooling, we're going to see as a type of bool. The next type we are looking at is the list. A list is used to store a changeable set of data. So in a list, we have something like names of fruits. Let's call it fruit, and then we give this mango and give this orange. Now, if we check the type, is the type of names of fruit is a list, and I'm going to be explaining the difference between list and tuples because they are always being confused. So if you check the names of fruit, you're going to be seeing a list. And now the difference between a list and a tuple is that a list can be changed. So I can move on to the list, which is the index of the mango, which is 0, and I can change 0 to give me another value. So I'm going to append an element to the end of the list. So I'm going to come here and call updated elements, and I'll set this to be equals to the names of the fruit, and I'm going to append, should I say, apple. So if you go ahead and print the names of the fruits, you should keep in mind that there are only two items when we initialize the list, but when we print it, you are going to see a very different option. You're going to see 3, and that shows that a list can be changed. Unlike tuples, if you try to change a tuple, so if I change this to a round bracket and then you try to run the same function again, you're going to receive an error. And yes, because tuple cannot be changed, they are immutable. And the next one is a range, and a range is used to show a list of numbers. Next one is a dictionary. What is a dictionary? Dictionary is simply a set of key value pairs. So let's say, for example, we are storing an information about the user. So we say user info, and we set this to be equal to, should I say, the name, and the name is this, and we show is schooling, and we set this to be equal to true, and then there's supposed to be a comma, then we set the names of fruit, we set this to be mango and apple. So an object is simply a set of key value pairs where this is the key on the left and the values on the right. So you can see that object moves that problem of us having to create so many variables for things that are related. So you can see that everything at the top of this file here that was here might be related, like the names of the fruit and the schooling, the age and the name might be related to one person. So we can just create a user object simply, and then we can append the age. You can put in the age as a key and the value. You can put in the schooling, put in the names of the fruit and the updated elements as a key and a value to it. And if we print the user info right now, which I'm going to print, oops, I'm still having that error there. I did not clean that up, so I'm going to remove this and let's run it again. You can see that everything is being printed, and an object is a very friendly way to do this. Then the next data list that is there is the none, and the none is just simply used when nothing is passed to a variable, like there's no null, there's no dictionary, there's no string. You just give it a non variable, and it's just simply passing a none to something. So you can say whether it's married, and pass it to none. And if you check the type of is married, you're going to have a data type of none. So if you print the type of is married, and then we try to run it, we are going to have a data type of non type. So that's all about data types. The next thing we'll be looking at from here is the type conversion. So now data types can be converted from one form to another, and there are two methods of conversion here. We have the implicit and the explicit. Now in terms of implicit, Python automatically converts our data type for us. So I'm going to give you an example of an implicit right now. So let me comment this as implicit, and then I'll comment another one as explicit. Okay, so let's say we are given a price of a fruit. So maybe the fruit is a tangerine. Oops, it's supposed to be lowercase tangerine, and then the tangerine should be, should I say, about 3 cents or $3 depending on who you are. And then you have another fruit, pick another fruit, a mango. I don't really know the prices. The mango can be like, should I say, 2.5. Now if you notice and you look into these values, you can find out that this is an integer and this is a floating point number, because this is a decimal and the other one is a whole number. So if you try to add these two, which we can do, so I'll print tangerine Okay, let me do it like this. So I'll call the price of fruit. Let's just look formal, and I'll say this to tangerine plus a mango. So if we print this price of fruit, now as a very normal human being or a programmer, we are expecting Python to automatically add it for us, and that's just what's going to happen. It is adding the integer to a floating point for us automatically. So, and that is very very good, and thanks to the Python interpreter for doing that for us. And we see this in most similar cases, and this happens for the implicit, where simple things like floats and integers can be converted between each of them to enable the Python processor to flow free without giving the developer a knowledge of what is doing at the back, which we call abstraction. Now moving forward, the explicit now on the other hand allows the user to automatically pass the type conversion. So I'm going to do it right now. So let's say we are going forward to buy some books. So we bought our first books for let's say we bought a book. We just buying collection of things. So we bought this book for 200, and we bought a pen for about 20. Okay, let's say mistakenly passing a string here 20, and then we bought a should I say an eraser for 8.5 here. Alright, so what is going to happen here is that when we try to add this, remember that integer and floating point number can be converted through each other automatically, which we call implicit conversion method. And what is going to happen here is that if we try to run this normally, we are going to catch an error. So let me show you. So let me call this total price. I'll say this to books plus pen plus eraser, and if we print the total price, let me go ahead and make sure that there's no other print statement that is covering what we're doing. I've commented that out, and let's run the file again. We receive an error. We see that unsupported operand types for plus integers and string. So it shows that integers cannot be added to string. So the basic way to do this is when you see the pen and you know that the pen is a string, you can convert it to an integer simply. So you can come here and wrap it around with a round bracket, and in front of the round bracket you use an int keyword, and if you run it again, we're going to receive the output, which is 228.5, and that's the output. And you can do this for similar things like that. I want to just make an objection here that if your pen is a text like hello world, let's also use hello world, it's very common, and you try to convert it to an integer, you're going to catch an error because Python cannot convert letters to numbers, and it's not normal for that to happen. You can see the error here, value error, invalid literal for integer with base 10 hello world. Okay, so that's the objection I wanted to make, and down to the next part we'll be looking at, which is the user input. Now every program should always be able to enable user input. That means the user should be able to provide what he or she wants. So that's where user inputs come into play. So to get in the user input from the terminal or from anywhere, we use the input keyword, and it's really simple. So I'll just comment this print statement also. This won't obstruct the way. We'll say username. Let's say username. Let's say I want to get the username. We'll come here and call the input built-in keyword, and we'll ask the user what is your name. I'll keep a space there so we could be able to maybe edit it comes out nice in the terminal, and then we can maybe print the username at the end, print the username. So let's try and run this, and let's see. Oh, I forgot to remove this. Just try and run this again. So what is your name? I'm going to put in manuals here, and then can see outputted manuals here. So now let's say I want to concatenate a string. Like I want to say, hello manuals, welcome to this program. How am I going to do it? Now there are two ways to do this. I'm going to show you the old method and the new method. Now the old method is actually just using the username here and using a comma. You put in the text you want to say, manuals, welcome to this program. And if you run it again, you can see manuals, welcome to this program. That's very fine. Now imagine we are trying to build a more complex program and then we need to maybe write something in front and write something in back. It's very simple. You just put a colon here and write it again, but it gets more complex, and Python released an f string later for us. Now an f string is very simple. You just need to put an f before the string, and then whatever variable you are trying to print, you put inside a curly braces. Okay, a lot of English, let me explain. So this is the string, so you put an f before the string and then welcome to this program, and then the variable we want to display, you put it in a curly braces and using the username. Now if you run this comes out more nicer. What is your name? And you can see welcome to this program manuals. So that is actually how to handle a user input well and how to handle the results coming out using literal strings, which I've talked to. There are just some few things I want to say before I talk about the project we're building today. Now I want to talk about variable naming conventions. Number one, variables can begin with an underscore. Yes, they can begin with an underscore, so you can name it price and it's going to work very fine. The second thing I want to also say is that variables can contain only alphanumeric symbols and underscores. So a variable cannot contain this. Consider there is already a comment putting that there. If I put that inside here and I try to run this program, the Python interpreter is going to scream out to me and tell me that this is happening. Okay, so a variable can only contain alphanumeric symbols. And the next thing you need to know is that variables are case sensitive. So price and price are two entirely different things. So if I print price right now, you see price is 3.5. I'm going to clean up this one here. Let me asterisk this. If we print price right now, you can see it's 3.5. Oops, this input was supposed to be shown. Okay, you can see that price is 3.5, and if we print price again, I'm going to quit the terminal. You can see that it's 4.5. So variables are case sensitive. They are not just like other programming language that okay, pass price, as far as it is price, it's the same variable. That is another thing you need to note about variables. And the last thing you need to know is that you don't just name variables anyhow you want to name them. So imagine I come and try and I want to name this variable, I call it x equals to manuals. This is actually, the Python interpreter is not going to scream, but it's actually wrong, because as a programmer you should be able to write code that an outsider can come and easily look at your code and understand. So giving your variable names, meaningful names, are going to be very helpful. So where you should be giving something like is available, you should not be giving something like y or z or t or giving it a letter. Instead you should name your variables very well, so even when you fall back to the code, maybe in a few months time, you'll be able to understand the code without looking for references and the rest. Okay, so that's enough of it, and this is the program I wanted to build today for me. So this is the project I'll be looking forward to you to build today. So I wanted to build a program that once a user types in this name in the terminal, you can see the file stated in our folder. So once I type it in, it asks me my name, and I'm going to just pass it in. Ask me my age, pass it in, profession. I'm going to pass it in, and maybe I'm going to pass it in, and then it generates a simple bio for us. You can see the little design here, the little text here. Hello everyone, meet Manuals, 18 years old, who works as a student in their free time. They love football. So pause the video, give yourself within 5 to 15 minutes and try to get everything running. When you come back, I'm going to just come and analyze the code. I'm not going to build it from scratch. We'll just analyze everything together. Pause the video right now. Okay, so welcome back, and this is the program. I'm going to analyze everything. This is a variable name which takes in the username. The next variable here is the age, which asks the user age. The next variable is the profession. The next variable is the hobby, which asks the user for his hobby, and this is actually the greeting that we just a template greeting that I wrote, and this is the little design we saw. And then this is the print statement, which is an F string, and we put in all these features: the bio greeting, the name, the age, the years old, the bio profession, and everything like that. So if your code worked well, the same my own did, it does not need to be exactly what I wrote, but even though it worked well, it did very well, and that's very nice. You can feel free to add many things to the project too. If you found this video helpful, do well to hit the subscribe button, because in the next video we'll be talking about conditional statement, then we move on to loops. Thank you for watching.